What is the connection between iced tea and the law of conservation of mass? Today, we are going to find out. Today, we're going to learn about the law of conservation of mass, and we're going to learn about how to balance chemical equations. If I had 250 grams of iced tea and 50 grams of sugar, and if I added this sugar into the tea, how much mass is now in the iced tea? So once again, if I had 250 grams of tea and I had 50 grams of sugar and I combined these two things together, how much would I have? I would have 300 grams of yummy goodness. This is known as the law of conservation of mass. Mass cannot be created or destroyed. So everything, all the mass needs to be accounted for. This principle applies to chemical reactions as well. This here is known as a synthesis reaction. And we don't know how much oxygen, how much mass of oxygen we have. We know that we have 32 grams of magnesium. So that's the purple atoms there. And when they combine together, the combination is 75 grams. So the question is, how much oxygen did I start with? How much grams of oxygen? So let's take a look at how we do this, if you don't already have the answer. So we want to figure out how much oxygen we have, how much grams of oxygen. So we simply do the opposite operation. So we're going to subtract 32 grams. And whatever we do to one side of the equation, we have to do to the other side. So we're going to get 75 grams minus 32 grams. So oxygen is going to be equal to 43 grams. Because everything needs to be accounted for. This is known as the law of conservation of mass. Mass cannot be created or destroyed. All right, next, let's talk about how to balance chemical equations. So this here is a simulation, and we're looking at another synthesis reaction. Remember, synthesis is when two molecules combine together and create one molecule on the other side. So the first thing we want to do is just do some accounting. We want to count how much atoms we have in our equation. So we first need a coefficient. That's the number right in front of the molecule. So we need to have one there. Now, when you look at chemical equations on paper, you're not going to have a 1 in front of the molecule. This is just understood that if you see the molecule, then it's one set. But for this simulation, for this model, we need to put a 1 in front of it. All right, so let's do some accounting. How much nitrogen atoms we have? That is the blue atom. We are going to have 2, right? Just take a look at the subscript. So what is in front of N? We have 2. And we could also look at the blue atom. We can count the circles. Next, let's look at hydrogen. And we see, once again, we have a 2. We have a subscript of 2. So we have 2 hydrogen atoms. We could also count the number of hydrogen atoms. And then there's a reaction that occurs, and it yields, or it produces, NH3. So let's count how much nitrogen we have on the right side. We see that we have 1 nitrogen atom. And we have 3 hydrogen atoms, right? Once again, the subscript. So the question is this balanced? It is not balanced. So we need to account for our atoms. So we can do this. We can actually use this tool right here. And we go down to the graph. And we can see that we have 2 atoms of nitrogen, 2 atoms of hydrogen, 1 atom of nitrogen, so that's not balanced, and we have 3. So where do we start adding coefficients? The rule is we want to add coefficients to the molecule that has the most amount of atoms. So let's take a look. N2 has 2 nitrogen atoms. H2 has 2. So let's take a look at the molecule NH3. We have 4 atoms. So we have 1, 2, 3, 4. So we want to add coefficients to NH3. So let's go ahead and add, let's make this a 2. So now we have 2 nitrogen atoms and we have 6 hydrogen atoms. So let's take a look. Nitrogen is 2. Nitrogen is 2. We are good there, right? So the question is, how can I get hydrogen to be balanced? We have 6 on this side and we have 2 on this side. Let's take a look. We're going to add coefficients to H2. We have 4. We have 6. Is it balanced? Not yet. So let's add another one, Oh yeah. So now we see that it is balanced. We have 2 nitrogen atoms on each side of the equation, and we have 6 hydrogen atoms on each side of the equation. So the recipe to make ammonia, which is NH3, is we need 1 set of N2, right? 1 set. And we need 3 sets of H2. And that is going to yield 2 molecules of ammonia, NH3. Today you learned about the law of conservation of mass, and you learned how to balance chemical equations.